Welcome at the panel entitled Ocean-Based Solution for the People and Planet. My name is Emilia Jankowska, and I'm a senior research fellow working in Project Drawdown in the ocean sector. Ocean protection has gained increasing attention within national and international authorities to avoid further degradation of natural ecosystems, to restore fish populations, and to sustainably manage ocean resources, so important for the future generations. It has been also recently underlined that ocean may play a crucial role in climate warming mitigation. There are different mechanisms of ocean protection and a variety of benefits that it brings. And today we are going to hear about them. We'll provide the latest scientific evidence proving the importance of ocean for achieving drawdown. We'll also dive into how we could accelerate and achieve sustainably managed ocean. We'll first introduce the Project Drawdown ocean-based solutions and then feature a few experts working in areas related with drawdown work. The first expert is Carlos Duarte, who is a distinguished professor at the King Abdullah University of Science and Technology. He will introduce current research on blue carbon sinks and nature-based solution concept, and what benefits do they bring in climate warming mitigation. Second speaker is Rashid Sumaila, who is a professor of ocean and fishery economics at the University of British Columbia. He will walk us through research on economic, social, and food security issues in the global fishery. Third speaker is Bren, who is a Greenwave executive director and the owner of Temple Island Ocean Farm. Will offer insights into regenerative ocean farming. And finally, fourth speaker, Susan Gardner, who is the Director of Ecosystem Division of UN Environment Program, will offer research insight of effective marine protection and restoration. Susan will also introduce the UN Ocean Decade main objectives and the future of ocean health in the 21st century. Let's dive into the first talk right away. As a marine biologist, my education and career are connected to the ocean, but I also have a very emotional attachment to the ocean. It is the most amazing feeling when you dive into the sea and experience the wonder of marine life. It is also a monumental moment when you experience the true power of the ocean and realize your own fragility. Everyone has its own connection to the ocean, but one common thing for every human being on Earth is the fact that we all depend on the ocean. The ocean covers the majority of the Earth's surface and plays a crucial role in regulating the climate by absorbing huge amounts of CO2 and excess heat. Despite the major role that oceans plays for humanity, we haven't treated it very well. It is experiencing many threats such as habitat degradation, biodiversity loss, acidification, heat waves, and widespread pollution. All of those threats cause cumulative impacts, reducing the ocean capacity to regulate the climate. For many years, we are treating the ocean as a victim. Fortunately, there are already many initiatives all around the world that are trying to change the ocean's future. Let me just mention the UN Ocean Decade that started last year and gathers different stakeholders so they can work together to ensure ocean science delivers greater benefits. Moreover, last December, 14 countries has put forward a new ocean action agenda committing to sustainably manage 100% of the national waters as a part of high-level panel for sustainable ocean. Therefore, the moment is now to change the narrative of ocean health from placing it solely as a victim to regarding it as a part of a solution. Based on our drawdown analysis, the solutions rooted in the ocean are necessary for the transformation of the whole system and solely are avoiding or reducing a significant amount of greenhouse gases emissions. A set of ocean solutions comprises two main groups, a group of protection and restoration, and a group of approaches to improve fishery and aquaculture operation. The two groups of solutions together have an impact on securing food production, a food that has usually a low carbon footprint. Therefore, in the next months, we are aiming to model a diet shift solution that will test how much greenhouse gases can be avoided by partly replacing meat consumption with a seafood. First, we'll focus on the sector of protection and restoration solutions. All of them act as a blue carbon sinks. Thus, their protection or restoration brings benefits of carbon sequestration and storage for a long time frame. Coastal wetlands consist of seagrass, mangroves, and salt marshes ecosystems. Relative to the land area, they sequester huge amounts of carbon in plants above ground, in roots, and in soil below. Macroalgae has also a great potential for carbon sequestration, and kelp forests in particular are one of the most productive ecosystems on Earth. Another blue carbon sink that is very often omitted is the seafloor sediment. It represents the vast majority of the ocean floor, and in many areas, it is still disturbed by bottom trawling that replace large amounts of sediments together with stored carbon. For each of these solutions, the potential climate impact was determined by estimation of the so-called total ocean area. It represents the total area available for a given solution. For example, in case of macroalgae protection, it is the global area suitable for macroalgae growth. Similarly for coastal wetlands. The total ocean area of seafloor protection represents the global area of mud sediments disturbed by bottom trawling gear within exclusive economic zones of the countries that still allow for this type of fishing. As a next step, we collected data of the average annual carbon sequestration rate and calculated the annual amount of CO2 emissions avoided per hectare by applying protection and restoration, for example, by establishing marine protected areas or bottom trawling bans. The total drawdown potential of protection and restoration solutions is between 3.3 and 7.6 gigatons of CO2 reduction in a 30 years timeframe. Coastal wetland protection is having the highest potential of maximum 2.5 gigatons carbon reduction, and it is followed by macroalgae forest protection with climate impact up to 1.8 gigatons reduction. Coastal wetland restoration and macroalgae forest restoration are having a very similar maximum impact of around 1.2 gigatons reduction. And finally, seafloor protection represents a maximum impact of 0.9 gigatons. The next speaker, Robin Pelc from Project Drawdown, will present drawdown potential of fishery and aquaculture-related solutions, as well as why additional benefits of applying all presented ocean-based solutions. Thank you for your attention.
Thanks, Emilia. I'm going to focus on ocean-based solutions to climate change related to fisheries and aquaculture. These are incredibly important sectors with a huge impact on ocean health. Seafood, farmed and wild, together contribute about 17% of dietary protein needs globally. When you look at small island developing states and coastal developing nations, seafood can provide the majority of both protein and other important nutrients for those coastal populations. In addition to this important role contributing to food security, fisheries and aquaculture also add about $100 billion to the economy and over 250 million jobs, making it one of the most important employment sectors in the world. The good news is that compared to other high protein foods, seafood can be produced with relatively small carbon emissions and can be a sustainable source of protein. But right now, many global fisheries and aquaculture operations have significant environmental impacts and room for improving their sustainability. To consider how changes in the fisheries and aquaculture industries could serve as ocean-based solutions to climate change, we modeled 3 potential solutions. First, we considered carbon sequestration through seaweed farming, which is a growing industry that can be used for a variety of purposes, like food, biofuel, or aquaculture and agricultural feeds. Secondly, we modeled improved fisheries management, in particular, reducing overcapitalization and excessive effort in order to reduce the fuel emissions from fisheries. We also considered how sustainably managing fisheries in this way could increase large fish biomass and the resulting increase in carbon sequestration from sunken fish biomass in the deep sea that would occur as a result of rebuilding large fish biomass. Finally, we modeled improving aquaculture by reducing its reliance on fossil fuels through installing hybrid energy systems. For each of these solutions, the potential climate impact was determined by estimating the total potential for adoption. For fisheries and aquaculture, this is in terms of the total weight of seafood that could be produced under improved fisheries and aquaculture management. And in the case of seaweed farming, this is in terms of the total ocean area available for seaweed farming. We collected data on these maximum adoption potentials and potential avoided carbon emissions per hectare that can be achieved through improving fisheries and aquaculture, as well as average annual carbon sequestration rate for seaweed farming, using a combination of literature review and data provided by subject matter experts. For each solution, we modeled a range of scenarios ranging from more conservative assumptions to more optimistic adoption assumptions. The resulting climate impact in terms of the cumulative gigatons of carbon dioxide equivalent from 2020 to 2050 are shown here, with the smaller inner circle representing more conservative assumptions and the larger outer circle representing results under the more optimistic assumptions. We found improving fisheries and aquaculture each could avoid a gigaton or more of carbon dioxide emissions over 30 years, while seaweed farming could sequester between almost 5 to 15 gigatons. Zooming out now from fisheries and aquaculture related solutions to consider the full scope of ocean-based solutions that we discussed today, we can see that in total, these ocean sector solutions could help draw down between 9 and 24 gigatons CO2 equivalent between 2020 and 2050. The solutions achieve this drawdown through a combination of reducing sources of emissions and increasing carbon sequestration in the ocean. If we are able to achieve these goals, in addition to the climate impacts, these solutions would help provide a lot of ancillary benefits as well. For example, by protecting coastal wetland habitats, this would help provide protection from extreme weather events and from coastal erosion. Improving fisheries and aquaculture could help sustain livelihoods in coastal communities and increase food security. And protecting benthic habitats and protecting and restoring macroalgae forests would increase biodiversity and ecosystem services in the ocean. To actually achieve the drawdown modeled here and bring these solutions to reality will require work on a variety of fronts, including proactive policies from governments to protect their ocean and coastal habitats and to manage their aquaculture and fisheries sustainably, innovation and investment in sustainable practices from industry, and collaboration between NGOs and local communities. There is hope that these solutions will begin moving forward. And one of the bright spots is the commitment, which was mentioned by Emilia, made by 14 countries, shown here in the map. These countries have committed to an ocean agenda following the recommendations of the High-Level Panel for a Sustainable Ocean Economy. Together, these countries manage 40% of the world's coastlines and 20% of the world's fisheries. And they have each committed to managing 100% of their waters sustainably. Specifically, among other priorities, they highlight the need to fully protect 30% of the ocean, end harmful fishing subsidies, and halt the destruction and increase restoration of coastal and marine ecosystems, including mangroves, seagrasses, salt marshes, and kelp forests. These are all actions that would help to increase the adoption of the solutions that we've discussed today. The Drawdown ocean-based solutions would help support the UN Sustainable Development Goal 14, Life Below Water. But through the various climate and other benefits they offer, they would also help to support and enhance a number of the other UN SDGs as well, including reducing poverty, hunger, and inequality, increasing health and well-being, supplying clean energy, and helping promote decent work and economic growth, and supporting climate action and life on land. Through a sustained effort, collaboration, and innovation, these goals are within reach, and solutions from the ocean have a potential to play a large role in a more sustainable future. Thank you for listening to the Project Drawdown Ocean-Based Solutions part of the panel. We will now move to our invited speakers. First, you will hear Dr. Carlos Duarte talking about nature-based solutions and carbon sinks.
Hello, my name is Carlos. I'm a marine ecologist working on marine ecosystems across from tropical to polar ecosystems, and I will be introducing blue carbon, the blue carbon concept and blue carbon habitats. So blue carbon refers to habitats in the ocean, in the margin between land and ocean, that have a huge capacity to lock carbon in the sediments and therefore remove carbon dioxide from the atmosphere. These include seagrass meadows, mangroves, salt marshes, and algal forests. And even though they are relatively occupying a small part of the seafloor, less than 0.2% of the seafloor, they're actually responsible for about half of the total carbon buried in the ocean. And their carbon sequestration capacity is 10 to 50 times higher than the carbon sequestration capacity of forests on land. And even if we look at the champion of carbon sequestration on land, that arguably will be the pristine Amazonian forest, a hectare of seagrass in the Mediterranean sequesters as much carbon as 15 hectares of pristine Amazonian forest. And it does that in the seafloor and raises the seafloor as it packs carbon on the meadow, in the soils in the meadow. So because we have lost about half of the global extent of these habitats, there is an opportunity to contribute to climate change mitigation by conserving these habitats, therefore preventing further losses, but also rebuilding these habitats. And this strategy was coined with the name of blue carbon in a report that I co-authored in 2009, along with other colleagues from UN agencies. So since this concept of blue carbon has been adopted by many nations as part of their nationally determined contributions to climate change mitigation, but yet there's one component, algal forests, which is not yet considered and included, and this is because most algal forests grow on rocky shores and they export the material, which ends up sequestered partially in the deep sea. And it's very hard to then apportion that carbon sequestration to a particular wild seaweed forest and any action that has been done to conserve or restore that forest. So this component of seaweed carbon is really not actionable, even though seaweed contribute to carbon sequestration as much as salt marshes, mangroves, and seagrasses combined. And then we drew attention to this component as being the elephant in the room of blue carbon. And we then consider how we could turn seaweed carbon sequestration an actionable action within blue carbon strategies. So the path that we are following is actually looking at seaweed farming as an expanding activity that is actionable, controlled, and where the fate of carbon is traceable. And about half of the production of the seaweed is actually released in the environment before harvest, and much of that ends sequestered in the carbons in the soils below the farm. So we are now quantifying that component of carbon sequestration that had not been quantified so far. But then there's also other benefits for a drawdown from seaweed farming, because once you harvest the crop, then this can be used to also contribute to further reducing greenhouse gas emissions. And for instance, there's recent research that shows that if we feed ruminants 0.1% of the diet with dried seaweed, this reduces methane emissions by 40 to 80%, while also improving animal health and the quality of the products, including dairy products. And because emissions of methane from ruminants is about 14 to 18% of global greenhouse gas emissions, this actually is a very important contribution of seaweed farming to a reduction of greenhouse gas emissions. And in addition to mitigating climate change while growing on the sea, and also as we use the crop to also generate further climate benefits, seaweed farming is actually an industry that's empowering women in the developing world, who are by and large the seaweed farmers, and also improving the livelihoods of people in Asia and Africa. So there are multiple benefits in this new contribution to the blue carbon family. And now we're also looking at animals as a component of blue carbon, large marine animals. And just consider that the reason why we have depleted whales to 20% of the former abundance is not because we hunted them for meat, it's actually we hunt them to burn them. So we hunted whales for the oil that was used to light the streets of Europe and North America in the 18th and 19th century before it was replaced by gas and coal. And therefore, much of carbon that used to be whales is now part of the carbon dioxide in excess in the atmosphere. So if we would rebuild the abundance of large marine animals, and in particular the large whales, which is a doable challenge and it can be achieved within 30 years, that alone will contribute to about 0.8 petagram carbon per year additional sequestration. And there are many other ways in which we can conserve marine animals and increase the stocks of large marine animals to the former abundance, and through that also contributes to enhance the functionality of the oceans and the capacity of the oceans to draw down carbon dioxide. So the family of blue carbon that started with vegetated coastal habitats is now expanding into also including large marine animals in the ocean.
Thanks everybody for joining the conference. It's a pleasure to get to talk with you. The title of my talk is Why We Should Stop Overfishing and Rather Rebuild Fish Stocks. So that is the topic, and let's get going. My first point is that the ocean is too large to ignore. In fact, some of us think we should call the planet Earth planet ocean because it's 70% of the Earth's surface. It's important in so many ways that I will explain some of them as we go. And what I usually tell students is that if you keep scoring 30% in your exams, you are not going to go anywhere. So if we don't take care of 70% of the ocean, I think we end up in real trouble. I mean, we, humanity. Now, this is my very simple model of the relationship between our economies and the ocean, our economy and the environment. Essentially, what we have here is a model that shows what we do when we go to the environment or to the marine environment, to the ocean. We take the things we like the fish, the oil, the gas, all the good stuff the environment gives us, we take them into our economy. And we do all the stuff we do with it, economics, cultural, social stuff, all the eating. And what do we generate? We generate waste, and this waste goes back to the environment, to the ocean. So this model, what it says is we have to be very careful how much we take and how we do the taking. If we overdo it, we're going to mess up the whole system that is actually supporting it. The same thing with the pumping out. If we pump out too much CO2 or too much debris into the ocean, plastic, then we're going to kill the very important renewable natural resource that we have. Now, talking more specifically about overfishing, there are three elements of overfishing that I want to highlight here, and they have consequences. Number one, we simply take too much fish that nature can regenerate. So that is classical overfishing. That's one. Now, we also like to take the big, valuable fish first. So you start fishing. This was described as fishing down the marine food web by my colleague, Daniel Pauli. What usually happens is we take the big, valuable fish first, then we go to the next, and we go to the next, fishing down the marine food web. And this has consequences because we are truncating the marine ecosystem and all the relationship between different types of fish and animals in the ocean. It's an ecosystem. It's a system that is connected, and the food web is connected. When we take big fish, we're actually disrupting that as consequences. The third thing we do is the kind of gear we use to fish. We use bottom trawlers, and what you see at the bottom is over time the richness of the habitat is being destroyed. We are banging and just destroying the habitats of fish, and so when you take too much fish, you take big fish and you destroy the habitat, you are actually destroying the whole system that we depend on. And this has to stop. That's what I mean by stopping overfishing is important. Otherwise, there will be no fish for us or our grandchildren in the future. Now, like I was saying, I mean, I'm an economist, so my relationship in this case, I love conservation, I love biodiversity. All my love for them is also connected for my love for people, because as people, we need to be alive. There are certain things we need. We need food, for example. And if you destroy the food source, you're actually messing up people. So in the first graph here, on my left-hand side, you have what we have shown by the FAO and by our group at UBC. We are taking more and more fish from depleted systems, and that has consequences. This guy is saying, is that all the shrimp I get after all this work on the water? And the lady down there, she is actually what we're beginning to see more and more, environmental refugees, because their food systems are being taken down by climate change and overfishing and all the environmental hazards, erosion and deforestation. All this are happening. And that's pushing people out. And human beings don't just sit down and die. They are forced to migrate with all the consequences. So this, seriously, conservation, biodiversity has big effects on people. And that is another reason why we have to really take good care of it. Now, I talked about taking big fish and disturbing the ecosystem and life in the ocean. That more and more science is showing that the more we do that, the more we aggravate climate change, because it leads to less fish in the ocean. So we have to search more, we have to go far, we have to go deep, we have to burn more carbon, and that contributes to climate change. So that's one channel. Number two, the animals themselves actually sequester a lot of carbon. And so when you take the whales, instead of them dying and taking the carbon in them and storing them, we release the carbon. And this picture shows you different mechanisms through which life in the ocean actually helps us to sequester carbon. In a study we did, we compared the values in terms of economics of catching fish in the high seas, that is, in the areas beyond national jurisdiction, and selling the fish. What value do we get? Versus if we allow the fish to remain in the water and sequester carbon, how much value do we get? Because they are doing it for us instead of us. And what we found, it was a 1-to-10 ratio in favor of carbon sequestration in terms of economic value. So that's the kind of thing we are talking about. And if we overfish and deplete our systems, we are actually losing this important function. So to wrap things up, essentially what I'm saying is that we need to make sure that people and the ocean, people and nature live in harmony. And this will depend a lot on the policies we put in place and the actions we take as people, individuals, companies, NGOs, and governments. A good example here is subsidies, actually. Our governments give about $35 billion subsidies to fishing companies around the marine fishing companies around the world. This is about 30 to 40% of the gross revenue of the sector. Just imagine that. A lot of these subsidies go to generate fishing, which shouldn't be there in terms of economics. I mean, because if you are losing money year in, year out, we will have to stop. But if the government is paying 30% of your gross revenue, you can keep on fishing and depleting the fish store and making things worse. What is more, most of the subsidies goes to large industrial fishing fleets, not the small-scale community-based ones. So you are aggravating inequality. You are depriving young people from getting into fishing. You are depriving women. So you have gender inequality, lots of things in here. That leads to negative feedback from people to nature and nature to people. What we need to do is to design policies, take actions that lead to positive feedback. For example, if you use the government, the taxpayer money to help people to retrain and learn other skills in the fishing community so they don't have to hang on the last fish, that gives the fish a break, the fish grows and can support the community more. So this is the kind of policies we need to put in place in order to ensure that people and fish live together in harmony so that we can continue to benefit from this amazing, wonderful natural resource that we have. Thank you very much for your attention.
Hey folks, honored to be here. Love Drawdown, what a cutting edge organization. So thanks for bringing me in today. I'm going to talk quickly about what is regenerative ocean farming, why we think it's a solution in the era of climate change. So I was born in Newfoundland, Canada, former fisherman, dropped out of high school, and over time ended up in the aquaculture farms. Now, aquaculture was interesting, right? It was exactly what we don't want to do as a solution. It was intensive monoculture out in the ocean, huge fish pens, pesticides, antibiotics, using wild fish, right? And I think the mistake aquaculture made was it grew around existing markets. Folks wanted to eat salmon and tuna, so we grew salmon and tuna. Instead of asking the ocean, what do you want us to grow? What's unique about the ocean as an agricultural space? And when you ask that question, what the ocean says back is, why don't you grow things that don't swim away and you don't have to feed? And that opens up an entire world of 11,000 different ocean plants, hundreds of kinds of shellfish. And let's put people like me to work rebuilding those ecosystems, breathing life back into our oceans by growing, our underwater rainforests and our underwater shellfish reefs. So that's what I did. And what we've developed over time is something we call regenerative ocean farming. And just let me show you a couple pictures here. We give you a flavor of what we do. So there's the farm. It's really pretty basic, right? Some anchors, some ropes, some buoys. We grow our seaweed vertically downwards. Then we grow mussels in mussel socks. We've got oysters in lantern necks and scallops, and then mud down in the surface. The idea is to grow as many species as possible in a small area, like have that small footprint. My farm used to be 100 acres. It's down to 20 acres, and I grow a lot more food than I did. And here's the crops, right? There's the kelp. It's a winter crop post-hurricane. We call it a shoulder season crop. You've got mussels in mussel socks, and that's, lean proteins, less of a carbon footprint than lentils. We got our oysters and our scallops. And here's the farm from the surface, right? And there's not much to see. This is really important for social license. We've got over 192 permitted farms around the country, and there's not one basically industrial fish farm off sea. And the reason is that we've got a low aesthetic impact, right? And that's so important. Our oceans are these beautiful, pristine places, and it's not privatized. Anybody can boat, fish, and swim on our farms, so we protect the commons. Now, why we think this is an important model in the era of climate change is, one, it's regenerative, right? We filter, oysters filter nitrogen out of the water column. It's zero input food, no fresh water, no fertilizer, no feed. So as the price of inputs go up for other foods, our food is going to become some of the most affordable food in the planet. Like the climate economy winds are at our back. Our crops function as carbon sinks, rebuild reefs. So it's regenerative, but it's also replicable. So anybody with 20 acres in a boat, 20 to 50,000 can get going. Think of it as a nail salon model in the sea, which is key for fast replication, right? And to move at the speed that we need in climate change. And it's scalable. If you farm 5% of US waters, networks of farms, you'll absorb 135 million tons of carbon and create the protein equivalent of 3 trillion cheeseburgers. Now, one of the questions is, what does scale look like? Is it 1,000-acre banana plantations or 10 100-acre farms distributed, and one goes to a corporate vertically integrated model where the benefits go at the top? The other, what we think of as Greenwave reefs, the benefits are distributed, but you get just as much production. Now, what we did to scale the industry was create a Greenwave. At Greenwave, we've got two programs: farmer training and support, and a digital platform, and then we have a market innovation program. And so training, let me back up and do Greenwave. So to scale the industry, to spread it, we created Greenwave, a nonprofit. We've got two programs. One is training and support, and the other is market innovation. Our training and support program is targeted at indigenous communities and fishermen, directed at climate change, right? It's got a social justice focus. We permit, we do site planning, we do hands-on training, virtual training, leadership development. We have a buyers network, so we ensure that farmers can sell their crops. And then we have a digital platform, a toolkit farmer dashboard so they can record data, digital co-op, blue carbon, auction. These are all things that we're rolling out. We've got a waiting list of over 6,000 farmers in the US who want to get going and started. Now the question is, where's all this, especially seaweed, gonna go? And we have a whole leaf strategy. From my farm last year, this is where our crops went. One went to Akua and some other companies to do plant-based burgers, kelp flowers. It went to another section of the crop went to bioplastics, so turning seaweed into plastic alternative straws and packaging. And then the third avenue was agriculture, using it for fertilizer and compost, which is so important, right? Land-based farms need nutrients, and we're able to capture carbon and nitrogen and micronutrients and bring it into the soil for soil sequestration and really build a loop between land and sea farming. Let me jump out of here. You know, what's exciting for us is that we get to build something beautiful out in the ocean. Like, let's do food right this time. Let's not privatize our seed. Let's protect the commons. Let's ensure that justice is woven into the DNA of this economy, right? While we do drawdown of carbon, let's lift up communities at the same time so that we get jobs, justice, and climate mitigation all packaged together. I mean, right now we look at our oceans as these frightening places, right? Rising sea levels, we're building seawalls, we're fleeing the coast. Let's instead turn around, embrace the ocean, see it as a space of climate solutions. And let's build something really where we can all make a living on a living planet and tap into that blue collar innovation. And let's turn millions of people directed into addressing and solving the climate crisis. So thanks so much. And let's hand it over right now to Susan Gardner.
I'm Susan Gardner, the Director of the Ecosystems Division of the UN Environment Program. We all know the problems. There's a growing awareness that oceans everywhere are under intense impacts, but at the same time, there's growing demand for their benefits. The world's oceans are a massive resource for sustainable development. So let's focus on solutions. I'd love to leave you with an overarching message that a healthy environment is the best foundation for economic prosperity, human health, and well-being. Through the use of sustainable practices in marine and coastal ecosystems, we strengthen a blue economy that can support economic, social, and environmental benefits. But to make this point, let's look at nature-based solutions, COVID recovery, and why the time is now to ensure that real change occurs in this decade. So starting with nature-based solutions, healthy ecosystems have the potential to deliver enormous benefits. This is part of a response to climate change, biodiversity, and human health challenges. They can deliver 1/3 of the climate mitigation needed between now and 2030, equivalent to 10 to 12 gigatons of carbon dioxide per year. However, ecosystem-based approaches to climate change have the potential to be exponentially scaled up with additional investments, especially in the marine area, because right now they only receive a very small share of climate finance. And their true value to climate, health, and economies is only just beginning to be appreciated. Although this last year really raised our collective awareness of the interlinkages between our health and that of our planet. The UNEP Executive Director, Inger Anderson, recently said that COVID is sending us a message, but it's like an SOS signal to bring into sharp focus the need to live within our planet's means. And that leads me to my next topic. Investing in healthy ecosystems in the ocean is key to COVID recovery. As we're approaching the end of this year that turned out not at all like any of us had imagined, it's a year in which the world was hit by a global pandemic that changed the way many of us work, live, and play. And as governments prioritize the recovery of their people and their economies, it's essential to understand that investments in ecosystems have the potential to ensure that COVID recovery results in building back better and greener and bluer. The blue stimulus options for COVID can deliver both short-term and long-term benefits, delivering goods and services from the ocean that generates 2.5 trillion each year and creates over 30 million jobs. Scientific evidence suggests that to secure a healthy, productive, resilient marine environment, at least 30% of the world's ocean must be safeguarded in a network of well-managed marine protected areas. But we know what to do, and we have sufficient tools and know-how to reduce human impacts and enable people to live in harmony with these oceans that sustain us. And this leads me to my last point. Now's the time to ensure real change. Now's the time to unlock the full potential of nature and ensure that we have transformative actions that are fully integrated into decision-making. Marine protected areas can reconcile biodiversity and fisheries management objectives and generate mutual benefits across many different interests. But we have to remember that quantity does not equal quality, and global conservation efforts shouldn't be undermined by accrediting protected areas that don't meet at least some minimum requirements for ocean recovery. But marine protected areas are effective when they're part of a comprehensive ocean planning and management process. We also have very practical lessons that are ready to available to assist countries to include coastal ecosystems as part of their NDCs for the Paris Agreement. So now's the time for transformative action. And we can do this as part of the 2 UN decades that are just beginning. The decade of ocean science for sustainable development and the decade on ecosystem restoration. Over the next 10 years, we have an unprecedented opportunity to drive applied science and solutions. The Ocean Decade will convene a wide range of stakeholders to align their research, investments, and initiatives around a set of common priorities so that the result of their shared effort is exponentially greater than the sum of the parts. UNEP is also proudly leading, together with FAO, the UN Decade on Ecosystem Restoration. Degradation of land and marine ecosystem undermines the well-being of 3.2 billion people and costs about 10% of the annual global gross domestic product because of lost species and ecosystem services. But the decade can accelerate existing global restoration goals. For example, the Bond Challenge, which aims to restore 350 million hectares of degraded ecosystems in the next decade. It's almost the size of India. We will form close linkages between the 2 decades to accelerate ocean conservation and restoration and generation of science-based policy advice. So in conclusion, the world did not meet any of our global biodiversity targets that were set for 2020. Yet this year, countries will get together in Kunming to forge the post-2020 biodiversity framework to halt the extinction crisis and put the world back on a pathway to live in harmony with nature. If anything, COVID-19 has shown us that we can work together, and when we do, we can achieve an extraordinary pace. We've learned that this is within our power. And just as the pandemic has shown us how inextricably linked we are to nature, it's also shown us that we have an incredible capacity to change, and that we can, in fact, alter our old ways when we have to. Similarly, we need to see global warming not as inevitable, but as an invitation to holistically rethink, rebuild, innovate, and affect change. And I commend Project Drawdown for being a leading resource for information and insight about climate solutions and partnering to accelerate climate solutions globally. This decade is our time to join forces and align all of the innovative solutions that are presented here today into something that's much bigger than what we can do individually. And at UNEP, we look forward to working with all of you to progress solutions and actions for people and planet. Thank you.
Thank you, Susan, and thanks to all speakers. During the last 40 minutes, we could listen to interesting and inspiring talks that all relate to fixing our relationship with the ocean. We heard that coastal ecosystems are ready to be a part of carbon credit system, but that we need to scale it up globally and include more components such as seaweed farming. The way we approach seaweed farming is also crucial because it has to be sustainable, like 3D ocean farms or by including renewable energy resources. It has to be small scale and economically feasible by local farmers, quite an opposite to industrial aquaculture. We also have to improve the fishery that right now largely relies on harmful subsidies, promoting industrial fishery and leading for injustices within coastal communities. It is important to realize that everyone has a role in this transformation, our governments, industry, and the society. We need to invest in healthy ecosystems. We need effective and comprehensive ocean management to ensure we can live in harmony with the ocean so we could continue to use its resources. By fixing our relation with the ocean, we could not only fight the climate warming, but also many other challenges that we are facing today or that we will face in the future, such as degradation of natural habitats, biodiversity loss, food security, justice, gender equality, and even recovery from COVID-19. We hope that we have inspired you for taking action and helping to restore our oceans. Thank you.